issue with 421? Okay, then today's lesson is very, very simple. I would like you to look in your book, and please, if you don't have a book, share with somebody, because I need you to see the problem. Page 431. Page 431. These are word problems, but they're very, very simple ones, and they involve concepts that you're already familiar with. So this will be easy for you, I think. Page 431, problem number 1. The angle of elevation of the top of the cathedral from a point 300 feet away from the base of the steeple is 60 degrees. Find the height of the cathedral. Now, they drew the picture for you. I will not. You are responsible for knowing how to draw your own pictures. Okay, are we missing somebody today?
I'm gonna move your hat for you if that's okay.
So here's the deal. Here's the cathedral standing on the ground. This is question number 1, but you don't have a book, Taylor, so you have no idea what I'm talking about. Question number 1, here's the cathedral. I am standing out here looking up at the top of the cathedral. This is called my angle of elevation. When you look up at something, that's your angle of elevation. They tell me that the angle of elevation is 60 degrees in this problem. What else do they tell me? There's one other thing they tell me. Where am I standing? 300 feet away from the cathedral. So here I am. Here's the cathedral. I'm looking up at the top of the cathedral. Now, what am I supposed to be figuring out? How tall is the cathedral? Now, I want you to read problem 1. Shh. I shouldn't hear any talking. I want you to read problem 1. I want you to look at where I put the 60, where I put the 300, and where I put the X. Does all that make sense to you? Because you have to be able to do that by yourself. Then, you need to figure out which trigonometric function, sine, cosine, or tangent, is appropriate in this problem. So think about it now. Here's your angle, 60 degrees. Which side is this? Opposite, adjacent, or hypotenuse? Opposite. Which side is this? So which function should I use if I've got opposite and adjacent involved in the problem?
TOA,
Tangent. TOA, tangent. So the tangent of 60, the tangent of the angle, equals opposite over adjacent. The tangent of the angle equals the opposite side over the adjacent side. Now, you're going to be able to use a calculator on all of these word problems. So we're going to solve for x. So won't we just multiply by 300? So we will just type into our calculator. Please make sure you're in degrees first. Set your calculator in degrees. And type 300 tan 60. The height of that cathedral is 519.62 feet. Now, I want you to have a piece of paper out, and I want you writing these down. Why? Because they're your homework problems. I'm doing some of your homework for you. So get out a piece of paper, write down problem number 1, and this is how it works.
So how'd you, Miss Ward, how'd you know to use tangent?
How did we know to use tangent? Tim? In the there's three sides to the triangle. Two of them are labeled. The two that are labeled are the opposite side and the adjacent side. So I need to use whatever function is involved with those two. Okay. All right, so now I'm going to look at problem number 2. Again, if you don't have a book, you are severely hampered because you can't read the problem. You need to be able to read the problem. From a point 100 feet from its base, the angle of elevation to the top of the arch is 34 degrees, 13 minutes, and 12 seconds. How tall is the monument? All right, so we're going to draw a picture of this. Here's the monument. Somebody is standing out here looking up at the top of the monument. Would you agree with that? How do I know we're looking up? What's the key word in the problem? Angle of elevation. Right here. This is my angle of elevation, looking up. How big is that angle of elevation? 34 degrees. There's more to it. 13 minutes and 12 seconds. And we're going to review how to put that in our calculator in a minute.
Why do you have to have the minutes and seconds if there's like a degree?
It's like, if I were going to measure the length of the hallway, I could just say it's, 20 feet long. To be more precise, I might say it's 20 feet and 3 inches. This is just a more precise way of measuring it. So rounded off, that would be 34 degrees. But we've broken it down so we can be more precise. All right? Now tell me what I know. What else do I know? I'm standing 100 feet from the base of the tower. Here's the base of the tower. I'm standing 100 feet away. What am I trying to find? The height of the tower. So the first thing you have to be able to do is draw that picture. If you can't draw that picture, you cannot get the right equation, because your equation is going to come from your picture. And the equation you write is going to be either a sine, cosine, or tangent equation. So what do you think? Take a look at it. What do you think? One more time, it's going to be tangent, because involved in the problem are these two sides. This side's not involved in the problem. It's not labeled. This is opposite. This is adjacent. So I'm going to use tangent again. Tangent equals opposite over adjacent. So what I'm ultimately going to type into my calculator, remember you're trying to figure out x, so you're going to multiply by 100. You're going to type 100 tangent 34, 13, 12. Now let's review how to do that. Once again, my calculator is set in degrees. So I'm going to type 100 tangent 34. Now I need the degree mark. If I didn't have all this stuff, I wouldn't need the degree mark, but I need to separate the 34 so the calculator knows that's 34 degrees. Who remembers where to get the degree mark? Second angle, or second apps, is the apps button. Second angle, and right there's the degree mark. So I press enter and it pulls that up. Then I type 13 and go back into second angle. Go down to the minute mark. And then I press 12, and here's where it gets tricky. Because I don't go back in the second angle, do I? If I want my second symbol, where do I find that? Alpha plus. And the height of that tower is 68.01. Yes.
How come, you couldn't insert in that and like find the, decimal, and plug that?
You absolutely could.
Okay,
Oh,
but how
my
come you
God.
couldn't remember?
Okay, we probably did it wrong then. So I'll have to look at that. When we're done, I'll look at that, okay? Okay, now I want to look at question number 3. I am not going to do every one of your homework problems, but I want to do 3 because it involves a new vocabulary, well, a different vocabulary word. I don't think it's new to you. Read question number 3. The angle of depression. Now, angle of elevation means looking up. Angle of depression means looking down. So it says, I'm at the top of the lighthouse. So here's the top of the lighthouse. And I am looking down to the buoy out here in the water. So here I am looking down at the buoy. My angle of depression is 10 degrees. I wish I had a nickel for every kid that put the 10 here. I would be rich, and they are all wrong.
You wouldn't be
The
with
10
me.
is not there.
You wouldn't have any nipples.
The angle of depression is always measured from the horizontal. This is the angle of depression. It
can
is
feel
the
that.
same as the angle of elevation. They always match. So most of the time, I don't even write it up there, I write it down here. Here's the thing. If I am looking at the seagull, my angle of depression is 10 degrees. If the seagull is looking at me, his angle of elevation is 10 degrees. These are alternate interior angles. They always match.
Okay.
You will never put a measurement here. Never. It's either going to go here or it's going to go here.
Two choices.
And since those always match, I always put it here. Because that's in the triangle. That's not even in the triangle. So I like to put it down here. Now what else do I know? I know what? The height of the lighthouse. How tall is the lighthouse? 120 feet. What am I trying to figure out?
How far the lighthouse is from the buoy?
How far the base of the lighthouse is from the buoy?
Oh, we're trying to find the lens.
Here's the buoy. Here's the base of the lighthouse. How far is it?
I got you.
Now, I want you to listen, because this always causes confusion. If I said, this is me up here, looking down at the seagull on the buoy. If I said, how far am I from the seagull? That would be this, right?
Mm-hmm.
But that's not what this question says. It says, how far is the buoy from the lighthouse? That's this. All right, so let's look at our triangle. Again, which function are we going to use? Tangent. And this time, our equation will be tangent 10 equals what? What is the tangent of 10 equal? 120 over x. Now, these are a little bit harder to solve when the x is in the denominator like that. So let's multiply both sides. Get rid of the fraction. Is that okay with everybody?
Yeah.
And now I'll divide by tan 10.
That might be so
Now, I don't need degree marks and all that stuff. I just need to type in 120 divided by tan 10. And that distance is 680.55 feet. Okay? Now I'm going to skip ahead and I'm going to do problem 10. So would you look with me at problem 10? Now here's the bad news. There's no picture at all for number 10. You are totally on your own.
That's not fair.
So here we go. A ramp leading to a freeway overpass is 470 feet long and rises 32 feet. So if you think about, here's the highway, here's the overpass, here's the ramp that you go up, like when you get off the interstate, you go up the ramp to the top of the bridge. The ramp is 470 feet long. Where am I going to put the 470? Now read it, and literally the ramp itself is 470 feet long. Where does that go?
That's the hypotenuse.
That's the hypotenuse. This is the ramp, boys and girls. If you are driving up the ramp, this is where you are driving, right here. That's 470 feet long.
Fire.
It rises 32 feet.
That's the height.
That's the height.
Don't mess with me, Miss Ford. I'm on fire. Go.
What is the angle of inclination of the ramp?
Yeah, you can put it in the bottom left corner. And
This is X. Would you agree with that? That is your angle of inclination.
and it appears to me this is going to be another tangent problem.
You are going to write an equation using sine, cosine, or tangent. Why would we use sine? You are correct. Why would we use sine? This is which side?
Opposite.
This is which side? Which function involves opposite and hypotenuse? Sine.
Good call, bro.
So we'll say sine x. I don't know what that angle is. I'm going to say sine x equals 32 over 470. When you want an angle on your calculator, that's what we're looking for, is an angle. When you want an angle on your calculator, what button do I press? Uh-oh, this was Friday's lesson. Did nobody watch the video?
No, I watched it. I watched it.
When you want an angle on your calculator, you press the second sine button. So we will press on our calculators, second sine, 32 divided by 470 equals, and that angle is 3.9 degrees. There is only one time you use this button, or this button, or this button. There's only one time you use that button, and it's if you need to find the angle. If it's the angle that's missing, if it's the angle that's missing, you're going to use that button, or this button to find it. That's how you find an angle. You never, ever, ever use these buttons unless the variable is the angle. If the variable is something else, you don't use those buttons. Let's try one more. All right, let's look at number 6. This is the last one, then we're going to do some practice quiz questions. Let's look at number 6. Hope you're keeping track of these because I've done half your homework for you.
Ooh, this
Number
is
6.
Ooh, I like the way you were solving problems nowadays.
A wire stretches from the top of a vertical pole to a point on level ground 16 feet from the base of the pole. Now, there is no picture for this problem. That picture goes with a different problem. You are on your own with problem 6. We have a vertical pole. A wire stretches from the top of the pole to a point on level ground. So here's the wire. Where do I put the 16? Right here. It says it's 16 feet from the bottom of the pole. Where do I put the 62 degrees? Right here. Isn't this 62 degrees? Do not be confused, boys and girls. It says the wire makes an angle of 62 degrees with the ground. Here's the wire, here's the ground. That's 62 degrees. Find the height of the pole, I'll call that H, the height of the pole, and the length of the wire. So this is a two-parter. There's 2 things you need to find. It doesn't matter which one you find first, but whichever one you find first will determine what equation you're going to use. So let's suppose we want to find W first. Let's say we want to find W first. What equation would we use to find W? What'd you say? Cosine. Absolutely. I'm going to say cosine 62 equals 16 over W. Take this out for a minute. I've decided just randomly to find W first. Does everybody understand why we chose cosine as our function?
Yeah, because that's opposite of hypotenuse. Oh no, adjacent.
Adjacent over hypotenuse. So W times cosine 62 equals 16. And W will equal 16 over cosine 62. (16) divided by cosine 62. W is 34.08 feet. Now let's find H. Forget W now. We're going to find H. What function will we use to find H? Tangent. And what will that equation look like, Brooke?
It'll be tan 62 equals x over 16.
Exactly. Tangent 62 equals opposite over adjacent. So the height of the pole is 16 tan 62. Whoops, 16 tan 62. So I got 30.09 feet. Okay, so tonight you will finish up the assigned problems. They're on that page. They're exactly like the ones you've been practicing. You will definitely need a calculator. Okay? Now what I'd like you to do is get out the worksheet that I gave you on Wednesday, the Review 4145 sheet.
How was retreat? It was good? Was it a good class? Good for you.
It was awesome.
Are you doing it again? And are you gonna be lean again?
Not this year.
Okay, I just don't get it. After what she did, I know they born again, like all these saints, all these saints disappeared. I don't know what happened. So did they feed you good food or something?
Oh, the food is hitting us, I believe.
They don't talk about it. You have to go.
Yeah, that's what.
But you need to go. It's wonderful. It's different for everyone. You need to go.
Maya, you should go in March.
Okay.
I'm going to March.
You going to move?
So we have review 4.1 to 4.5. Review 4.1 to 4.5.
Hopefully I can.
Number 2. I handed this out on Wednesday. You were to do it Thursday in class.
She said 4-1 to
Yeah.
Remember, it is from this paper that I am choosing. Yeah, you should have gotten that one. I handed it to you. It was from this paper that I am choosing quiz questions for our quiz tomorrow. So with that in mind, which ones do we need to practice? Brooke. Number 10. Now, you need to pay attention to the fact that this is no calculator. Because certainly we can find angles on our calculator using the buttons I just talked about. What are the buttons that we use if we want to find an angle? Second cosine, second tangent, second sine, right. But this is no calculator. So your job is to find any angle in the whole circle. Here's the whole circle. Your job is to find any angle in the whole circle that when you draw the triangle, the cosine would be root 3 over 2. Now, which quadrants could that even happen? Where the cosine was positive root 3 over 2.
1 and 4.
Certainly quadrant 1 would be a choice because everything's positive here, right? So would quadrant 4. Now before you start saying, ooh, how do you move? Stop and think. Cosine is x over r. If you want that to be positive, doesn't x have to be positive?
Yeah.
And where is x positive?
And where?
Quadrant 1 and quadrant 4. So what would this triangle look like? Let's just look at the one right here for a minute. That triangle would have a root 3 here and a 2 here. Agreed?
Agreed.
Cosine, adjacent over hypotenuse. If that's a root 3 and that's a 2, that has to be a 1. And that angle has to be how big? 30. Across from the 1 is a 30. You are simply sunk if you have not memorized your green sheet yet. After all this time, you still haven't done it. You are dead. You cannot be successful if you don't know that across from the 30 is a 1.
Is there still hope though?
Yeah, our test is Friday. Now, this angle would also be 30. They always match. I mean, the triangles are always congruent. So you don't need to do it, redo it. It's always the same. This angle is somewhere between 0 and 90, and that's a 30. So isn't that a 30-degree angle?
Right.
So one of your answers is 30 degrees. This angle is between 270 and 360, and that's a 30, so what's this have to be? 330.
What?
Because that's 30 right there. 330 to 360, that's 30. So the two answers to the problem are 30 degrees and 330 degrees. Let me do the next one.
We're done. We're done.
Listen, if that's a little fuzzy, pay attention, we're doing another one. Now, think of this as a fraction. You need the tangent to be negative. Now, remember, tangent is y over x. If that fraction is going to be negative, then doesn't that mean one of them is positive and one of them is negative? You got y and x, one of them is positive, one is negative. Which quadrants does that happen in? 2 and 4. So your triangles this time are in 2 and 4. Right?
Right.
Now, the tangent is opposite over adjacent. You should recognize that triangle. This is a root 2, that's a 45 degrees. Again, I can't help you with that. You got to know it. This is also a 45 degrees. They're always equal. So your answer is this angle and this angle. Now this one is between 90 and 180, right? And that's 35. So what would this have to be? 135. And how did she get 135? 180 minus 45. Now what about this one? It's between 270 and 360, and that's a 45, 315. So the answers to the problem are 135 and 315. If I ask you to do this, kids, the triangle is either going to be a 1, 2, root 3 triangle, or it's going to be a 1, 1, root 2 triangle. It has to be. They're the only ones you know by heart. Otherwise, I have to give you a calculator. Great question. All right, who else found something that we might have a quiz over tomorrow? Maya. I mean, we will definitely have a quiz tomorrow, but it'll be over. I'm going to pick, I've decided, I'm going to pick 5 problems off this. Okay, so number 12. So the cosine of 195, or no, excuse me, 395. I am finding the sine, S-I-G-N, of the cosine of 395. So I just want to know, if I typed cosine 395 in on my calculator, would it be positive, negative, or 0?
Negative.
Okay, well, I don't know. What does it depend on? It depends on which quadrant it's drawn in, right? So which quadrant would I draw 395? Well, now, wait a minute.
Uh-oh.
395 is big.
It's bigger than 360.
It's bigger than 360.
More than
So
so.
I'm going to take out that extra 360 and say 395 is 35 degrees more than a full revolution, right? So I would go all the way around, and 35 more, wouldn't it be here?
What?
If I went all the way around and 35 more, wouldn't I be here?
Yeah, you said
Tell me
that.
about stuff in quadrant 1.
Positive.
Everything's positive. So this is positive. It's sitting in quadrant 1, therefore it is positive.
Okay. There's a question like that on here.
What about the tangent of 11 pi over 12? Now, I need you to understand that 11 pi over 12 is 11/12 pi. It's not half a pi, and it's not a whole pi, it's 11/12 of a pi. So when I look at my circle, this is pi, and this is half a pi. Where is 11/12? Somewhere in between, right? Remember, this is 180. 180 is the same as pi. So pi is here.
You don't do the 180.
This is half a pi.
You don't figure
out the degree.
You can if you want, but I'm showing you don't need to. You're not going to have a calculator, so when I look at some of these numbers, I'm thinking, oh, I don't know about the arithmetic. Yes, Taylor, you can always, always change it into degrees.
You're not gonna calculate it.
You do not have a calculator. So that means it is important, not on this problem anyway, so it's important that you either do the nasty arithmetic by hand, or that you just kind of use your common sense. This is 11/12 of a pie. Is that a whole pie?
No, it's.
No. Is it more than half though?
Oh, for sure. For
So
sure.
it's more than half, but less than a whole, so it's in quadrant 2. And all I care about is which quadrant it's in. I don't need to know where to draw it or anything else, I just need to know which quadrant it's in. So it's in quadrant 2. Tell me about x and y in quadrant 2.
Y is positive, X negative.
Exactly. Now I'm doing tangent. Tangent is y over x.
So it'd be
What's going
positive
to
over-
happen when
positive
I
over-
put y over x?
Positive over negative.
Which is?
Negative.
So that answer is negative.
Okay, I got you. And that, okay, all right.
Cosecant negative 100. Now this is back to degrees. Remember, negative means go this way. So this is negative 90 and this is negative 180. Is it negative 100 in here?
Yeah.
Tell me about points x comma y in this quadrant. They're both negative. Cosecant is the reciprocal of the sine. Sine is y over r, so cosecant is r over y. Now r is always positive, you guys, always. R is always positive. In this quadrant, y is negative. So what happens when I put